The next field is destination prefix. It's a 128-bit IPv6 address prefix that refers the destination side. And the next field is prefix length, which tells about the number of significant bits in the prefix value. The next field is metric, which includes the value of the metric advertised for the address. And finally, the root tag field. So this is a root attribute. This should be advertised and redistributed with the root. Especially, the root tag distinguishes the external RipNG roots from the internal RipNG roots. And this is helpful when the roots must be redistributed across an exterior gateway protocol. So for that purpose, this root tag plays a major role. So these are the fields present in the RipNG packet header. And that is all about the RipNG protocol. Now moving on to the OSPF v3 protocol. We all know the OSPF is Open Shortest Path First Routing Protocol, and in that the version v3 it supports the IPv6 addressing. So we have some similarities and differences with the OSPF v2 protocol. The similarities are present in the link state database creation, intra and inter areas terminologies, the autonomous system external routes, and virtual links. In all these concepts, everything is similar, but there is some difference in few aspects, which includes peering is done through link local addresses, and the protocol in the link is link based rather than the network based. And finally, the addressing semantics. In there also there is some difference. This has been utilizing the leaf LSAs, which will allow the both IPv4 and IPv6. And the point-to-point links are also supported for enabling the operations over the tunnels. And also it is possible to enable both versions OSPF and OSPF v3 at the same time. Yes, OSPF will work for IPv4 and OSPF v3 will work for IPv6. There are few restrictions for IPv6 routing in the OSPF v3. That is, when running a dual stack IP network, we have seen in the tunneling and transition techniques about the dual stack concept between the host will be having two stacks, one for IPv4, another one for IPv6. In that case, you need to be a little bit careful because when changing the defaults for the commands, you have to enable the OSPF v3. At that time, you have to be careful about whether it's a version 2 or version 3 because changing the defaults can affect your network. So you can be a little careful when doing the configurations. Yes, next slide tells how the OSPF v3 works. The working of OSPF protocol. It's a routing protocol for the IPv4 and v6. We all know that OSPF is a link state protocol. So the link state means the link, which means the interface between the networking devices. So the link state routing protocol, it takes the decisions, routing decisions based on the state of the links that connects the source and destination machines. So that is the important point. So the link states are very important to take the decisions. And then this link state, what is that link state? It is nothing but the description of that interface and its relationships to the neighboring device. So that is the link state, and it contains some information, that is the IPv6 prefix of that interface, the network mask, the type of the network it is connected to, and the devices it is connected to that network. So all these informations will be available about the interfaces in the link state. So all these informations should be propagated. It should be shared. So this is done with the help of link state advertisements. So the next process is the link state advertisement. And A device collection of link state advertisement data is stored in the link state database. If suppose a router is getting a LSA from